Finally, we got to the end. Lesson 10. We'll go through the menu since nothing's changed much but the display. We've packaged everything up in their own little game object in the hierarchy. So we have our environment. We have UI. It's our game info canvas, which we're familiar with. We have our post-game canvas, which we're also familiar with. There hasn't been any changes made to these except for our buttons, how they're displayed. I did, however, add the vertical layout canvas and put the buttons within, which automatically groups them and displays them uniformly. We have an event system, which we needed, of course, to respond to button clicks. And we have our new background music. It has an audio source and a persistent music script. Now, before we go into the scripts, I'm going to open the window Audio Mixer. And in the Audio Mixer, this is Unity's new Audio Mixer. We put it to use. So the background music, as you can see, it's going to be played. Well, you can't see it's going to be played, but we have the menu scene here. And you just need to know what the menu scene is, and the menu music and the game music. The time to fade in and the time to fade out. So in our audio mixer, for each audio source contained in the game, when we head into the scene for the game, we'll see they all use this audio mixer, whether it's the sound effects mixer or the music mixer. So we no longer use the audio source to control the music. For this scene, it's very simple. It just uses this mixer and it plays. There's nothing to change. We're going into the game scene, however. If I can click on it. Oh, we need that. We have everything packaged up as before, but we have an effects. Here we have ground effects. I'll open the audio mixer, which uses the output here on the sound effects master mixer. The jump effects uses the one specified for it, and so on. So we have the pickups and the checkpoint, which is just the particle effect manager of sorts. So these all manage those effects. So in the mixer, we can start here for the ground mixer. We set the master mixer and we create a child mixer by adding one here. Right? So after we have the child mixer, I'm gonna delete that guy. You don't need it. So we have the child mixer, and we named it to sound effects. Could of course name them anything. We add a group for the sound effects. You notice they each have their own groups. We had a group for the sound effects and created new groups under each. Right, so this is a child of that one. Of course, and if I move it above, it's going to be a child of that one. So we want them to be, I guess, related in the same order that I have them here. So we have two mixers. So we have a master mixer as this guy. We have a music mixer under the master mixer, and we have our sound effects mixer under that. On our master mixer, we added one effect for each. Our duck effect and a send to send when the master mixer should duck the music volume. Right? This is not my where I rather live. I rather live in the code. But just a brief overview of how these things work, I think is beneficial for everyone. So we added our, this is a high pass, don't want that. Add duct volume, so it needs a send source, which we created here. So we can add a send source. Now you set the send source up, it needs to know who's going to be receiving. So we set it to master duct volume, which is the only one here, so it's going to show up twice. So once we set it, that's just the same as setting it. Then they're connected. So once they are connected, this is to taste. You find a decibel that works to where the sound effects get louder than the music, and you can have the music duck out to where these are numbers that I set that works for me, to where everything stays at a reasonable volume. So that's how those effects work. So everything goes through the master, and then it plays out for us. I guess we can look at the jump. Each of these guys now take care of what the audio source used to. That's how it works. So why don't we jump into some script? How do we persist the music? All right. So this is our component. You get into lesson 10 here. Persist music. We have a default volume, and this is the default decibel set to the audio mixer. So again, I'm not sure how all the audio stuff works, but I can write code, right? So now we make it a singleton. We set our values in the inspector, which audio clip we're going to use for each. And here's our scene picker again. Pretty handy attribute, if I do say so myself. So now, I mentioned this before, that on level loaded was being called more than once depending on what's going on, and I had to set a Boolean value here to make sure that whatever was called in on level was loaded was only done once. So sometimes you need to test your code to make sure things are happening as they should, and like you need to, you just write your code to make it work properly. So on awake, we do a don't destroy on load, we get the instance, and then we start the change music coroutine. This change music coroutine just runs out. It doesn't look when the level was loaded, it tries again. We get the audio mixer and the audio source. From that audio mixer, we get the clip, the name of the level name, see if it's the menu scene. Remember, we picked the menu scene up here, and if it is the menu scene, then we're going to use the menu music, and if it's not, we're going to use the game music. We see if we're swapping or if the clips are the same, and if they are, we break out of the coroutine. Everything's set as it should. So if the clips are not the same, of course, and we're not swapping, we set our swapping to true, and we start swapping. We get our volume from the current setting on the audio mixer. We check see if we do have a clip on our audio source, and if we do, we start the fade music clip. So we can fade in our music or fade it out. So this says fade out time, so I guess this call would fade the music out. And then we swap the file, the audio source, audio clip. We swap the audio clip on the audio source, and then we fade the music back in. So we call the same functions. So let's see how we get our volume from the audio mixer. Did I show that? We call the expose parameter to get the volume from the audio mixer. Expose parameter. We don't have any expose parameters on our sound effects mixer, but on our master mixer we do have one expose parameter, which is music vol, and you can set them as you wish. So for instance, I click here on my sound effects, click on jump, I can right click and expose parameters and change how they transition. So if we expose our volume parameter here now, we can access it via code. Okay, let's not do that for this one. So that's how I was able to access the expose parameter here. And now once you've exposed it, you can double click inside and give it a name that makes sense, that you can remember to use in code. Works like all the other parameters for Mecanim and these other things that Unity has. So here we are, we get the volume, so we can return what the volume is at start. Swap in the clip. Of course we set the clip, we wait, make sure our audio source is enabled. I ran into a few instances where this would happen and the audio source was not enabled yet, and playing it through an error. So we hang out here until the audio source is enabled, and then we play. This may happen, I guess, when it's loading the game scene. Maybe it might do a little extra loading. So that's why this was inserted. Now, fading the music, we get the time from 0 and we compare it to how much time we want to fade. And we do our nifty little time calculation. MathFLERP. MathF have so many handy little functions in there. So we use the lerp from the start to the end over the time. And here we are setting the music volume, the expose parameter on our audio mixer, to the current volume. And that's how this persist music component works. And with the don't destroy on load, we'll keep our same music component throughout all the scenes. So we have uninterrupted music. Okay, what else do I want to explain? Next, gotta explain them all. So we have our player, same components attached, except now our spawn point Y limit component has been, I guess, upgraded, and it itself has a few extra fields. Our auto collect, we saw that in our previous. We have a lives fall damage also attached to our player. Let's get into those scripts. I'll leave everything open so I can know what I've done. So our new spawn point limit Y has a life loss class attached to it. We mark it serializable so we can change it in the inspector if need be, and save the data to disk, of course, or wherever you can serialize the data. We get the amount of lives to reduce whenever lives are lost. We get access to our spawn point limit and our new game controller. We'll go over that here pretty soon. On initialize, we do just that. We get our tag player and our tag game controller from our tag utilities class. And reduce and respawn our player. I guess we reduce the lives of our player and we respawn, I guess. And reuse, yeah. Reduce, recycle, reuse, and all that good stuff. So in our lives lost, we have access here. This is what's going to happen from this component. So on start, we initialize our lives lost. And on update, we check our Y limit and we go ahead and respawn if we are at the Y limit. And this is in way back in our respawn class from our first lesson. That checks our Y limit on our player or any transform attached. So that's how we respawn our player now in lesson 10. We also have a lives UI that displays our lives, and this is also a scene view canvas. So it's right here underneath the player and it works pretty much the same as the speed canvas. There's a panel attached with the text in it that shows our lives, and we should remember this from previously, where we set the format how we want our text to be displayed. And then we have a follow canvas script attached and our lives UI script attached, which we're looking at now. So we get the text and we get the format how we want to display the game controller. In start, we let that run as an enumerator. We get our game controller and the format from our lives, and we display our lives to the lives we get from our game controller. Okay, straightforward. So we've seen our lives lost, we've seen our lives info, we haven't seen our lives info. So live info is the new data container that holds our lives and our level info, if you remember from the past. So that's how we keep track of the player's lives. Right, so it's lives info inherits from level info, so we can save this data out. Set our lives to 0, and here's our implementation of the serializable requirements. We add lives, we get our lives from when it's deserialized. Have we seen fall damage? Or is that where? Okay. Now this is the last one, and it's tremendous. So we'll go through them one at a time, make sure we step over each one. So the player has a fall damage script attached, which does what it says. It checks for the fall damage on the player. Here we use lives lost again to see what we do when the player loses lives. We get a fall velocity. This is new. Let's check that out. So fall velocity has a maximum velocity that we can be falling at. So Y velocity, as that's going to be set here. It's just a container class. Right? This is where we declare a new one. We update the velocity that we're falling at, and we check to see if it's at that maximum velocity. So here's our fall velocity, and at maximum velocity of 20, we do something. Here's a Unity event that will invoke when we're, at the fall velocity. So in start, we get our mobile controller. That's the new. I guess we probably use mobile here because that's as far down the chain as I need it to go. So our controller is up to the active controller, I believe, or the animation controller. So we initialize our life loss, how we do that, and then we use our mobile controller and we get the ground jump, and we make sure that's grounded. And if it is grounded and we did hit something when we were grounded, which is obvious, but hey, you gotta check the stuff, because I think it crashed a few times on me because of that. Anyway, if that is the case, we see if we were at the maximum velocity allowed. So if we were at that velocity, if we did fall, if we hit the ground at too high a speed, we invoke any events that subscribe to say, yeah man, we hit the ground, and it should hurt us, and then we respawn ourselves with the lives lost. Here we update our velocity each frame. That's how we check to make sure we have or haven't exceeded the maximum velocity. So as a player is falling and it's losing lives, we know what this does. We respawn our player if it's falling beyond the limits of the map, and we hurt our player if it falls beyond a certain velocity. And we invoke these events. We've seen what the background music controller does. We went over our speed canvas in the previous lesson. Our lives canvas is new. We also seen how that works. Our info canvas displays data on the screen. Before we get into the FX game controller, let's see what's new in our effects themselves. So we have ground effects, now need to close them all. Jump effects, particle effects. I think there may be even some particle and light effects. Right, so each of these components are a sort of manager for each. So starting with the ground effects, we can set ground effects, and these are the pools that we're going to be learning how to do. So in ground effects, we require our audio source component. We declare references to those pools that we saw, a velocity pool and a FX pool. They're both the same but different. We'll see about that. Our controller for our player, whether the grounded puff has happened. Action to deactivate the pools. Action to update the fall velocities. And actions to activate the effects, the pool effects. So in Awake, we get components and we initialize our pools. The FX pool gets a particle system prefab and an audio source to play, and how many objects to instantiate to use in the pool. We get an offset to spawn and the actual particle array that we're going to use in the pool. The particle array itself is a custom class. Let's go over that. So each pool uses this object. Reference to the particle system, the audio clip attached, the game object, and an audio source to play the audio clip. When we create a new FX particle, we give it the particle system, the audio clip, and the audio source. If there is a particle system attached, then we get the game object and we deactivate it. Upon activation of the particle, this is what will be called by the user of this object. It takes a position in the world space, and if it does have a particle, because things could be null, then we go ahead and set the transform to the appropriate position, activate it, and play the music, and start the particle effects. If there is an audio clip attached, we'll play it. We have an audio effects utility to take care of that. So in the audio effects utility class, we'll step back through and end up back in the ground effects. In the audio effects utility class, we have a jump audio info, which takes a clip, delay, and a private timer. If it can play, then it will start the timer, and it will continue the timer and return to you whether yes, if it can or can't play. And this is the condition. We'll no doubt see that in use. And we reset our jump audio clip class. To play one shot, we get the audio clip and we play one shot. It's trivial, okay. Now we can try to play in the jump audio. So this takes the class we just described above, the audio source, and the jump info. And jump info is another class we even have in here. No, that's way back in lesson 3. So it gets the jump info and it monitors if the audio clip can be played. So I guess if the delay is past the time, and if we are grounded, whichever jump info this is. So remember, it can be a wall jump or whatever jump, your head jump, water jump, and we can jump if our input is active. We did press the jump button, then we can play the jump clip, and then we reset the jump audio. Now bringing this in here may seem like, oh, can't you just see if the clip was there and play it? Yeah, you can, but now you have everything that needs to play an audio clip coming through this one point. So if you need to change something, like delay each audio clip or make sure there's enough memory to play any audio clip, you don't need to check each part where you call play audio clip and adjust whatever you need to adjust there. You can adjust it all here in one place and it will affect everything. So we know how that works already, presumably. Okay, so we're coming out of initializing our pool, and we ended up in our FX particle and to our audio utility. So now out of our FX particle, from initializing our pool, now we can go into initializing our pool. Now the pool is index based, so just for now, I mean, there's many different ways to do things. It will start it the first in the index, and it will just go through them. So the next one in line is going to use it anyway. So put enough in the pool to maintain that order. The good thing is you don't need to check everything in the pool to find one that's working to spawn. You always have something ready. So initializing our pool will create an object to store all the effects in. We create a pool that our particles, the size that we need, however many we want to store in our pool, and we loop through the amount and we create one for each. So we create a new particle, we instantiate the prefab coming in, we give it the audio source and the audio clip. Make sure it has a game object, nothing funky's happened up here, and if it does, we give it a decent name. OVE. Okay, that works. Spell check, spell check. And we set its parent transform. That's what initializing a pool does. So we'll step out of initializing the pool and we'll be back when the pool's activated and deactivated. So now we've initialized all the pools. We add them all to one function to deactivate all the pools. We add them all to one action. So I don't know what they call, or see, it's combining. Beautiful. Love IntelliSense. So we're combining all of these into one string of calls. So not all the pools update velocity. So the velocity pools of course they track velocity, so we add those to the fall velocity delegate that we're going to be calling, and we added a lambda to our activate FX, so we know what to do whenever we activate a pool. So if we activate a pool, we make sure if it's a, oh, it looks like we're only activating the fall velocity pool here. This is cool. So we check, make sure it's at its minimum, at its maximum. We check that the condition applies, whatever condition we want to check for. If we want to destroy it, then yes, we do. And then we activate that item from the pool. And like I said, we'll be back, so we'll check the activation now that we're here. Activating a pool uses the current index and activates it at that position plus the initial offset for each pool item. Then we move the index to the next slot. Deactivating the pool, this is called constantly, and if there is a particle system, if it's active in the hierarchy and the particle system stop playing, then deactivate it. So that's how we will deactivate the pool. So on start, we've seen this pattern before, and we try to always deactivate our particles. On update, we check to see if we're not grounded. If we're not grounded, then we haven't set off a grounded puff particle. Run with me here. We get our hit variable, see if the controller's hit something, and if we have, we activate a pushable particle. If we hit a pushable, that's if the hit has a rigid body, that's the condition that has to be true. Remember, we're taking cool, here we are. We're taking the velocity pool, the condition, and the game object that we may need to deactivate. So if we do have a rigid body, then we're gonna go ahead and invoke. So both of these can be on screen at the same time. We can end up having two particle systems going off, one for destroying the pushable cube and one for just hitting the ground. So if we are hitting the ground, it's going to take a pool to work on, and the condition is always true, and we're not destroying anything. Again, the activate FX just activates any effect we pass in. It takes a pool, any type of velocity pool, a condition, and what to do if that condition's met. So after we've puffed away on our ground effects, we update our velocities. We have respawn effects here that can be called from another script, even in the inspector we've seen through Unity events. And that's how we call our respawn particle effects. Okay, so now we have jump effects. Jump effects uses the jump audio, two of them. It's one for hitting the ground and one for launching into the, oh no, this is wall jump and a ground jump. It says it right here. That's why you name your variables properly, where you can understand things. In Awake, we get components, and on start, we start monitoring. We try to play our jump audio, the ground effects, or the wall effects, depending on what's going on. Let's take another look at this. So if it can play, which simply means that the time has elapsed, and we're grounded, when we press the active jump button that we get from the jump manager, then we play. Okay, and that's what our jump effects does. We've seen the jump audio. So now we have a pickup effects also, We separate all the managers and let them each be responsible for their own thing. And we see one big benefit of that is small, manageable scripts. So our pickup effects uses our object pool, our FX object pool. It initializes it on awake, and it subscribes to the pickup broadcast. Whenever broadcast is pick up, it activates the effect. We have a checkpoint effects. Now the checkpoint effects, do I even need all of those? Yeah, it's a lot of them. The checkpoint effects uses a particle light effects. Let's get into that one. That one's a new one. I like this one. So it's a mono behavior that's going to be attached to each checkpoint to play particle and light effects for that checkpoint. So we get the particle system and the light, target color and time, and we describe how to set the color of the particle system and the light. So if we are not the target color, so we're trying to set a new color, and the time has been completed, that means the time has ran all the way through and the color is set completely from the old color to the new color, then we start again. So we set our duration of our time and we set the color appropriately. The particle systems, you can't there's no lerping the color, you don't see anything, you lose the effect. So the particle system, the start color changes, so when one particle dies out, the next particle will be at your new color. So it kind of provides the same effect. Our light changes color between its current and the target. So we declare one of them near light effects particle here. The delay, how much time is going to take to change once we get there, how long it should take, and we add some random ratios, random numbers here, so they don't all look the same. And I wasn't quite sure when I was looking at this. Maybe the numbers were too small for me to notice if they were changing at a random rate. But I guess I'll have to check that out. Get our color. We expose property to access our particle light and the duration. In start, we grab our color. That's the default color, and we set our particles system to that. Here we are with our start again. We use this enumerator, and we just continue setting the colors of our particles and lights. And that came from here. So that's how we set our particle light. So each checkpoint is allotted one of these scripts, and they have their references. Now each checkpoint, I think, gets one of those. We'll see. Hang on. Yeah, we'll see how that works. Each checkpoint gets one of the particle effect scripts. Particle light effect script. It's associated with it through this dictionary. So we get the active and the non-active colors, the inactive color. You can pick any one you want in the inspector. We get a reference to our spawn limit and a reference to our spawn limit, and we instantiate our dictionary. On start, we go through. We'll start, of course, as a enumerator that runs forever and ever, and then we check all the references, make sure our key is sound. We compare the spawn points to what was the last triggered by the player, and then we swap the colors if need be. So if you are the current the current checkpoint, your color will be the active color. Every other checkpoint color will be the inactive color. Whenever the game state is set to playing, we spawn a new set of particle systems because everything is destroyed from the reload of the scene. Spawning our particle systems, we spawn them one at a time. I thought this was on the inside. That's what I meant to do, but it's not broken, so I'm gonna leave it like that. Wanted to spawn them one, then you'll see them popping up as you change the time here. And anyway, we spawn our particle systems. We instantiate, we set their name, their position, transform parent, and we play the particle system and we add it as a reference to the list so we can monitor it here. So that's the checkpoint behavior, and that's what it does. So we've been through all the effects behavior. We've been through the UI. The environment is also boring but necessary. Always seen what that does. Our player scripts, we've explored all the new additions. And now we have a new game controller. Our FX game controller. It inherits from the UI game controller previous, and we're adding yet another game state. We add a lives, respawn delay, protected lives info. We've seen that's the new information that we've declared about the game. And here we expose it to the world. This is our explicit implementation of our interface and our explicit method to get the game state. We override how to load the game data, and when levels loaded, we load our lives info. That's the new data that will be loading. And if there is no file, then we know it's a new setting for the file, so we set our new lives to the max lives. Here we add our new game state. So when the state machine gets to that point, we know what to do. When we're respawning, we call this coroutine here that we're going to be using all over. So we have respawn. That's our new game state that we're going to be implementing. We override the complete game state. We also override the game over game state. And we override them all with wait before continue. So we have a delay between each state. So when we die, when we respawn, we wait a few seconds. So it's not all instant. We get our player. We deactivate control to our player. We set the game state to idle. If we remember, idle game state is just an empty method. We wait. Then we activate everything. Set the game state to the game state we would like to be in now. And then we invoke any actions that are required. For instance, on respawn, if lives equals 0, then we're going to, after performing all this stuff, we're going to set our game state to game over. To complete. If lives is not equal to 0 and we're responding, then we're going to set the game state to playing. Alright, and that's what is done here. On complete, this is the game state that we're gonna be setting everything to if we get when we get to the end. And this is the game state that we're coming from, that the game state we should be setting to right now. So the call here, we have the game state and the action. So wait before. So when we wait on complete, instead of just calling the complete action and headed to the main menu, we wait for a few. Set it to the game state. So idle will have us wait. Idle does nothing, the code. Then we hang out, then we'll set it to complete. And then we will call our base complete function, and also for the game. So that's what this wait before continue does. So we have all the functionality of our UI game controller, our levels game controller, our base game controller, and now we just need to perform respawn ability. And here we reduce the lives of our player. We take our lives, we minus however much we want to take off our player, and then we set the game state to respawn. So in here we have the FX game state, which we saw, lives info, which we saw. We've seen our audio effects, utility class, our checkpoint, our new game controller, the game state that we're adding, our object pool. We have not, however, seen our massive velocity pool. Of course, the code we use, we just inherit from our object pool and declare what we need, which is the velocity field. And the fall velocity, of course, we saw what that does, takes care of housing methods that define what's falling and if we have actually been falling. Our FX particle stores our sounds and particle systems to be played. We've been through our grounded effects that plays effects on ground when we're ground. Our jump effects, which are do sound for jumping on the wall and ground. A particle light, which we use for our checkpoints. Our pickup effects that happens when we pick up one of those pretty yellow spheres. Again, we've seen our fall velocity, lives fall damage that happens when that tracks our player, and if it hits the ground at a certain velocity or falls at a certain velocity, it triggers us losing a life or lives, depending. This is the new game data that we'll be storing, the level info, including our lives info. We have our lives info data tracker, which is the new data tracker that's attached in our main menu. We have lives lost that tracks the fact that we can reduce our lives. It doesn't track that we can reduce our lives, it gives access to our lives reduction. Inherit from our way overdue spawn point limit Y script. Our lives UI to display a world space canvas, shows how many lives we have left. And our music that never stops playing. So on that note, I will maximize on play and head to the main menu. Oh, that's what we got. I reset the scores. Cool. Let's see what we got. At a checkpoint, it changes. So if I die, respawn right there. Let's go get that other one now. If you hit the ground at a certain speed, you get your little dust balls. Let me see if I can slow down the jump a lot here. I guess I can't. Nothing. Jump high enough. So those are all the effects that we put in there. Alright. Then on to the next level. I can collect them all. Cool. So now we've completed our course, our lesson. Hope you've learned a lot. Don't forget to contact us if there's any questions, if we can help you in any way to improve your knowledge in C#. So let's change let's see, there's our spawn points changed, the colors to show the active one. Cool. Thanks again, and have fun. Create all your levels and share your experience.